Welcome! This is such a good example to practice. We need to rationalize the denominator. It means we need to remove a radical from the denominator. So we have this big cube root. Let's rewrite it like this. The cube root of 64x over the cube root of 7y squared. Now we can totally see the cube root in the denominator. So we need to get rid of the cube root from the denominator. And we will do that. Let's first look at the numerator. Can we simplify it? We have the cube root of 64. 64 is a perfect cube because 64 it is 4 cubed. You see, the exponent matches the index of the root and it simplifies to 4. Very good. So we can take the cube root of 64, which is 4. Let's keep looking. What if we have the cube root of 7 cubed? What is 7 cubed? 7 cubed, it is 343. So the cube root of 343 is 7. You see, the exponent matches the index of the root and it simplifies to 7. Let's keep looking. What if we have the cube root of y cubed? The cube root of y cubed will undo each other and it will simplify to y. I love it. This is going to help us. So, we are simplifying the numerator. So the cube root of 64 will be 4. And the cube root of x will stay in the numerator. Now, in the denominator, we have the cube root of 7y squared. We need to get rid of the cube root from the denominator. So, to do that, we are going to multiply the denominator by the cube root. And together, let's figure out what we are gonna put inside. We have 7 to the first power. We have 7 to the first power. And we need to have 7 to the third power. So we take the exponent 3, subtract 1, which is 2. It means we need to multiply 7 to the first power by 7 to the second power. So we can get 7 to the third power. When we multiply with the same basis, we add the exponents. So inside that cube root, we will put 7 to the second power, so that when we multiply the cube root of 7 to the first times the cube root of 7 to the second, we will get the cube root of 7 to the third. We will get the perfect cube under the root, exactly what we need. Are you following me? Look, we have y squared under the cube root, yes? Y squared. What do we need to have? We need to have y cubed. So we take the exponent 3, subtract 2, which is 1. It means we need to multiply y squared by y to the first power, so we can get y to the third power. Because y squared times y to the first, we have the same base y. We add the exponents. So inside that cube root, we will write y to the first power. So that when we multiply the cube root of y squared times the cube root of y to the first, we will get the cube root of y to the third power, a perfect cube under the root. I love it. Look, what you do to the denominator, you will do the same to the numerator. You're gonna multiply the numerator by the cube root of 7 squared, y to the first. You see? Do you see what we are doing? We are trying to get rid of the cube root. So let's multiply the things in the denominator so we can totally see it. Since it's the same cube root, we will just multiply what's inside. 7 to the first times 7 squared will give us 7 to the third power. Yes, exactly what we need. Y to the second power times y to the first power will give us y to the third power. We see that exponent is equal to the index of the root. The exponent of y is equal to the index of the root, so it will simplify to 7y. Okay, very good, I love it. Now let's multiply what we have in the numerators. 4 will stay, Since it's the same cube root, we will just multiply what's inside. So the cube root, and inside what do we have? We have x times 7 squared is 49, and then y. Very good. Look, when you work on math, give yourself time to understand. Do not pressure yourself to understand right away. You will figure things out. I believe in you. Now let's keep simplifying. So let's look at the denominator. The cube root of 7 cubed will undo each other. It will be 7. The cube root of y cubed will undo each other. It will be y. So in the denominator, we got 7y. No more cube root. I love it. Let's look at the numerator. We have 4. The cube root. Let's write 49 first because it's the number, right? And then we have xy. Very good. So look, this is how it's gonna look like. We can't take the cube root of 49 because we have the cube root, not the square root. We can't divide 49 by 7 because 49 is inside the cube root. We can't divide y by y because 1y is inside the cube root. So we rationalize the denominator. It means we removed a radical from the denominator. So this is our answer. It is okay that our numerator has a radical as long as our denominator doesn't have a radical. Did this video help you? Smash the like button and subscribe. Keep up the good work, and I will see you in the comments